Hello, hi, I'm Pratham. My ID is 2019A7PS051P, and my topic is blockchain and IoT. So, what is IoT? First of all, IoT is the Internet of Things, which are ecosystem of connected physical objects that are accessible through the internet. So, in simple terms, it means that anything that can connect it to the internet and be controlled or monitored using the internet from a smart device or PCs consists of the Internet of Things. There are five main components to the IoT. First are the things or the device. These are fitted with sensors and actuators. The sensors collect the data from the environment and uh, pass it on to the gateway, where as the actuators actually perform the action as acted after processing the data. So you can think of it as a car. So if there is a camera in the car, then the camera is the sensor, and the controls of the car will be the actuator. The second level is the gateway. The gateways they receive the data from the sensors and do some kind of pre-processing on it, and they also act as a level of security for the network, and then they transmit the data forward to the cloud. The cloud, the third layer of IoT, is where the data is collected. The cloud in simple way basically a set of servers that is connected to internet 24 by 7 and receives all the data from the sensors and does the processing on it. The processing is called analytics. The data after being received in the cloud processing is done. Whereas algorithms are applied here for panels of data. We can apply machine learning techniques or some statistical techniques to monitor the data we are receiving from the sensors. And finally, there is the user interface, the the end user application from where the user can monitor or control the data. These make up the five components of IoT. The uses of IoT are quite a few. There are sophisticated strips, sensors, and actuators that are embedded into physical items. We transmit data into the IoT network. The analytics capabilities of the IoT use data to convert insights into action, impacting business processes and leading to new reporting. Some of these ways are where this is applied is in logistics and transport for fleet management, goods tracking. Suppose, as we look at in a later example, that if the goods being transported need a particular set of conditions, and we can use our IoT devices to ensure that those conditions are met throughout the transportation. Secondly, for utilities like smart meter and smart grid management. So one example is how nowadays so solar panels are being deployed. So when a when a home is puts energy back into the grid, that has to be tracked. And IoT is a way to track how much energy the house put back into the grid. Other applications are in smart cities, smart buildings, and in consumer electronics like smart watches and health trackers. Industrial like the process control, environment, food monitoring, alerts, environmental monitoring. Like, we can also use it for storm detections, etc. And also for agriculture. IoT comes with concerns of its own. The main one of being security. There are expected to be over 6 million IoT devices by the end of 2025, and most of these devices have been designed carelessly when it comes to handling or device-related security risks. Most of these devices and artifacts don't get enough updates, while don't get critical security updates at all. This means that a device that was once thought to be secure when the customers was bought it becomes insecure and eventually prone to hackers and other security concerns. Has become a common occurrence for IoT devices to be hacked by malware such as Mirai, and then we used to launch massive DDoS attacks on the servers of Amazon, GitHub, Microsoft, etc. Another concern is data tampering. As analytics are performed in the cloud, it is a matter of trust on the entity to give reliable data. So in about IoT devices, they are not controlled by a singular entity. Else, the entity can manipulate the data to suit their own needs. The third major concern is the reliability of the network. There should not be any single point of failures. Currently, large computer and data storage clouds are built to analyze the traffic that is received from IoT devices, but these clouds require huge investment to set up and then become a single point of failure for the whole network. Even if there are two IoT devices sitting right next to each other, they need to communicate to each other through a cloud. They cannot establish a direct connection with each other. So the lack of peer-to-peer networking is an issue for IoT because the sheer volume of the network traffic that flows through them. Here is where blockchain provides a solution. Blockchain basically is a tamper-proof public ledger. Hence, we can use this ledger to track the activity of the device and validate and secure the data that that is being sent from the device. Hence, because there is a public record of the data being transmitted, it cannot be tampered with. The blockchain technology will also provide a peer-to-peer network that would be resilient, and there would be much less load on the clouds, and the network as a whole becomes more resilient. We'll take a case study here. This was provided originally by IBM. So they have deployed their own solution for use cases such as this one. Uh, so as we discussed earlier, a common application of IoT is in the supply chain. So we'll take a look at it in detail. And milk is produced in several. The journey of milk is in several stages. At first, at the dairy farm, the milking and initial storage is performed. This raw milk is not fit for consumption. It has to be processed. So it is transported to the dairy processor for testing, pasteurizer, and packaging. From the processing plant, it must be transported to the supermarkets or convenience stores. And then at the retail store, they have to stored in a refrigerated display unit. And finally, the consumers can purchase them. In this example that we are taking, transportation of perishable food stuff such as milk is regulated by specific conditions that ensure that it arrives at the point of purchase safely. To keep it safe for consumption, the milk must be kept chilled. If it rises above a certain temperature, it would be spoiled and be unsafe to drink later. So, to make sure that the milk always is at the right temperature in transit, one option would be to hire a person to sit with the lorry with a thermometer in his hand, and every 10 minutes or so the person would have to check the temperature and send the updates to the retail store, which, as you know, is not practical. We cannot have so many people uh, who would be hired for the purpose of just taking temperatures of the milk. Hence here, IoT is a solution. We can connect sensors and they would be taking measurements at every at fixed intervals of time, and whenever they will get a network, they will transmit the data to the central server. So we are connected sensors for data transmission. The individual packages contain milk are instrumented with an IoT-enabled temperature sensor. The sensor stores temperature data locally and sends it via the IBM Watson IoT platform to the blockchain. And the blockchain stores the temperature data where it can be viewed by each party to the transaction. Essentially, the connected sensors carry irrefutable evidence as to how the milk has been handled at each stage in its journey. Because sensors automatically collect and transmit data to the blockchain, there is no chance of recording incorrect data. Instead, the information is accurate, timely, and non-partisan. This protects each of the business partner by ensuring accountability. For instance, if one of the vehicles transporting the milk is inadequately refrigerated, the milk temperature will be shown to have exceeded the recommended limits. It's picked up by a sensor and transferred to the blockchain. And it will be immediately obvious when and why this happened, and who should bear the responsibility. The another advantage of using blockchain would be automated contracts, which we call as a smart contract in the blockchain industry. Business contracts are stored on the blockchain that would specify certain conditions that must be met. Control temperature might be one of these. When the data from collected temperature sensor reflects that this particular condition has not been met, the blockchain can automatically record that this part of the contract has been successfully completed or has been aborted. So this is one of the use cases that we discussed here. Now, let us talk about blockchains that are made to cater to these IoT devices. The largest one of them by far right now is Helium. The Helium blockchain uses a unique proof of work model, which is called as a proof of coverage. The blockchain uses special devices called as Helium long phi that provide network coverage to IoT devices, all the while mining cryptocurrency to make it profitable to the miners. So the requirements of a blockchain that is to be used with IoT devices is that it should provide a huge amount of computing power that should be usable to your devices, such as for packet forwarding. And it should not happen that, like Bitcoin, the most of the computation done is only to compute hashes and not do any externally useful work. So, hence Helium introduced the concept of proof of coverage. There are millions of compatible devices that can use the Helium network, also called the People's Network, and each device requires some data credits in order to send data to the internet. These data credits are fixed in value and are created by burning the cryptocurrency of Helium, which is called HNT. This reduces the total supply in order to achieve a burn and mid equilibrium for the cryptocurrency. The more devices that are using the data credits, the more HNT will be burned. So, in order to reward the miners, there are four ways. So, first of all, there are some challenges. These are hotspots that are chosen by the network to issue challenges. They send encrypted message over the internet to target a group of hotspots, and the challenges are used by proof of coverage to validate wireless coverage. Hotspots can issue challenges from any location, not just the local hotspots. The second is, and the most important, is the proof of coverage. Hotspots earn a share of HNT for participating in proof of coverage and validating the peer's wireless coverage. The amount each hotspot earns depends on how often it is directly involved in proof of coverage activity. The third way of earning rewards are witnesses. The witnesses are hotspots that monitor and report the proof of coverage activity. They are also called as beacons of other hotspots that receive a portion of the HND depending on how much activity they have witnessed. and the reward scaling of the challenging. And lastly, here comes the most important and the usable aspect, which is the data network transfer, network data transfer. The identity is distributed to hotspots that transport data from devices on the network. The amount of HNT is allocated proportionally based on the amount of data a hotspot transferred. So this was about. So now we shall be discussing some ways in which the IoT blockchain integration is actually being implemented. The first application is device firmware hashing. So the device firmware or the firmware is the main software that runs the IoT device can be hashed into a blockchain on a continual basis at fixed intervals. If the firmware state changes, if the hash changes, it uh, means that malware is altering the firmware code. Hence, the hash failure will alert the owner of the device that the device has been tampered with or is now compromised. The second application is instruction authentication. Information or checking instructions. So device hashes information it wants to send to another device and places the hash into the blockchain. Now the receiver of the information can hash the same information and check if the hash matches the hash on the blockchain. In case the hash does not match, it means that the information has been changed on transit and has been compromised. The third application to improve security is the device identity protocol. Each the device will be given a public key on the blockchain. The devices must encrypt the messages they pass to each other using public-private key e- encryption. So this will ensure that the device is in control of its own identity. The fourth way is the device reputation systems. So devices can be given cryptographic reputations as each device will have its own public key. There could be, for instance, a certification agency for devices which audits the device and then gives it an identity on the blockchain. Hence, once the device is historically born on the blockchain or registered on it, as we call it, the device identity cannot be reversed. The environmental inputs that are unique to the individual sensors, such as GPS, temperature, humidity, etc., may also be used in conjunction with the IMR or OEM firmware hashes to create the ultimate tamper-resistant unique device identification system. And then we also have IOTA, which is a protocol for fast transaction settlement and data integrity, with a tangle ledger that eliminates the need for expensive mining and validation of blocks. IOTA is a promising infrastructure for IoT devices that need to process large amounts of microdata. Features of the Tangle ledger, which is a distributed ledger that supports IOTA, are machine-to-machine communication, keyless micropayments, and quantum resistant data. IOTA has built a sensor data marketplace that is entering the market for data-driven insights, and it is being supported by 20 global corporations. By quantum-resistant data, we mean that in the upcoming age of quantum computers, the security of the traditional computers might be broken. So IOTA is working to figure out a way to protect the encryption in the world of quantum computers. So that's all. Here we explored an introduction to uses of blockchain in an IoT system. We learned that blockchain primarily improves the security and the reliability of IoT, which has been a primary concern of all the IoT systems. Thank you.